All right, if you've ever touched Kubernetes, you know the feeling. You see that dreaded CrashLoopBackOff status, and your heart just sinks a little. It's frustrating, for sure, but it's not some unsolvable mystery. In the next few minutes, we're going to turn that frustration into confidence. We're going to show you how to solve it every single time.
So there it is, staring right back at you from your terminal. Your pod is stuck. It starts, it crashes, it restarts over and over again. It can feel like a total dead end, but really, it's just the beginning of our investigation. The real question is, where do we even start?
First things first, and this is a big one. CrashLoopBackOff is not the actual error. Think of it more like a symptom. It's just Kubernetes' way of saying, hey, this container is failing so fast that I'm going to pause for a bit before trying again. Our job is to find that real error that's hiding inside.
So let's put on our detective hats. The pod is our crime scene, the logs are our witnesses, and that crash, well, that's the mystery we need to solve. We just need to know where to start looking for clues.
Every investigation has to start somewhere, right? We're going to begin by surveying the crime scene. Before we dive into the nitty-gritty, we'll look for those high-level clues, the obvious stuff Kubernetes has already found for us.
These are our first two tools, right out of the box. kubectl get pods, that's just a quick check to see, yep, it's still broken. But kubectl describe pod, oh, that's where the investigation really kicks off. It gives us a whole event history for that pod.
Down in the events section of that describe output, we find our first real leads. Is Kubernetes having trouble pulling the container image? Is it being OM killed? You know, the classic out-of-memory error? Or maybe a health probe is failing. Each one of these points us in a completely different direction.
Okay, we've got the lay of the land. Now it's time to zero in on our prime suspect, the application code that's running inside that container. Because let's be honest, most of the time, this is where the problem is.
The application's logs. I mean, this is usually where you find the smoking gun. It's the app's testimony, where it confesses exactly why it's crashing. But the key is using the right command, and specifically, that little -previous flag.
But wait a minute, why the -previous flag? This is a detail that gets so many people. If you just run a normal kubectl logs on a crashing pod, you often get nothing, just an empty screen. So what gives?
Here's the secret. The current container instance. It's brand new. It's in the process of starting up, so it hasn't had time to fail and log an error yet. The -previous flag is your time machine. It tells Kubernetes, show me the logs from the one that just died. That's where the evidence is hidden.
So what kind of dirt are we digging for in these logs? It's usually the classic stuff you'd see in any application. We're talking about things like a null pointer exception, maybe it can't connect to the database, or it's trying to use a port that something else is already sitting on. The logs will almost always point you right to the culprit.
Okay, but what if the logs are empty, even with -previous? Well, believe it or not, that silence is a massive clue in itself. It usually means the application didn't even get a chance to start, and the problem is with the very first command used to launch it.
And here are a couple of the usual suspects. Maybe your container image is built on bash, but your YAML file tells it to run with sh. Or a classic one, your startup script isn't actually marked as executable. These kinds of basic mistakes cause an instant exit, leaving no logs behind.
Now, for those really tough cases where the pod just dies instantly and you can't get in, we bring out the secret weapon, the debug container. This awesome command basically attaches a healthy little toolbox container to your broken pod's environment. It lets you poke around the file system, test the network, and see what's really going on.
And hey, don't forget to check the simple stuff, the configuration. Is your app actually getting the database password it needs from a secret? Is that API endpoint from the ConfigMap correct? A single typo in an environment variable name is all it takes to bring everything crashing down. Remember that killed event we talked about? This is what it looks like in practice. You've given your app, say, 64 megs of memory, but it needs more. You're basically suffocating it. The second it tries to stretch its legs, Kubernetes has to step in and terminate it.
And the fix? Well, it's often just as simple as it looks. You bump up that memory limit in your configuration, give the application some breathing room, and boom, case closed.
Okay, we've interrogated our container pretty hard. But what if the container is innocent? Sometimes the problem isn't the app itself, but the environment it's running in. It's time to zoom out and check the surroundings. Liveness probes are a great example. Think of them as Kubernetes poking your app to see if it's still awake. But if your app needs 30 seconds to wake up and get its coffee, and you start poking it after just 5 seconds, Kubernetes is going to think it's dead and kill it, even though it was perfectly fine.
And if you're seeing a bunch of pods failing on the same machine, maybe the problem isn't the pods at all. Maybe the whole neighborhood is bad. A quick describe node can tell you if the machine itself is running out of disk space or memory, affecting everything on it.
Finally, when all else fails, go back to the source, the blueprint, the pod's YAML file itself. You'd be amazed how often the problem is a simple typo. Trying to pull an image tag Lyle test instead of latest. It happens to the best of us.
So we've followed the clues, we've questioned the witnesses, and we've checked the surroundings. Now let's put it all together and crack this case once and for all.
This right here, this is your game plan, your step-by-step guide to solving this every single time. First, you describe the pod, looking for obvious events. Then, you check the logs with -previous. No logs? Check the entry point command. Still nothing? Validate all your configs and secrets. Then, check your resource limits and node health. And if you're really stuck, you bring in the debug container. Follow these steps and you will find the root cause.
So there you have it. You're not just a Kubernetes user anymore. You're a detective. You've got the toolkit, you've got the process, and you know how to solve the CrashLoopBackOff case. The only real question left is, what Kubernetes mystery are you going to solve next?